evening, everyone, and a very warm welcome to today's session on unearthing groundwater secrets with geospatial tools to address water challenges. It is a pleasure to have Dr. Vivek Agarwal, lecturer, Engineering and Environment Department, University of Northumbria, United Kingdom, in today's session. We welcome you, sir, and we thank you for graciously accepting our invite.
Pleasure is all mine. Thank you so much.
आपका बहुत स्वागत है सर. I also welcome Mohammed Tayyab Alam sir, Communication and Documentation Officer, Morarji Desai, National Institute of Yoga. We are very grateful, sir, for your kind presence and your valuable inputs that we get frequently on this program. So, as per the tradition of the Institute, we will begin the session with prayers. Astu ma sadgamaya tamso ma jyotirgamaya mrityurma amritam gamaya. Om Shanti Shanti Shanti. I again welcome the speaker, Dr. Vivek Agarwal. I also welcome the director of the institute, Dr. Ishwar Basavaraddi sir, from Morarji Desai, National Institute of Yoga. आपका बहुत-बहुत स्वागत है sir. The director of the institute has done remarkable work in the institute, and that has led to his appointment as the head of the Yoga Certification Board, Ministry of Ayush, Government of India, and has also served as the project director of WHO Collaborating Center for Traditional Medicine in India. We are privileged to have your gracious presence, sir. Now, I respectfully request Mohammed Tayyab Alam sir, Communication Documentation Officer, Morarji Desai, National Institute of Yoga, to introduce the speaker of the day, Dr. Vivek Agarwal. Please, sir.
Thank you. Thank you, Dr. Suman. Good evening, everyone. Respected Dr. Vivek Agarwal sir, lecturer at Northumbria University, has been into research in the field of geospatial environment engineering, focusing on addressing critical water resources management challenges. Having completed his postdoc and a PhD at the University of Nottingham, his doctoral thesis on groundwater properties utilizing geospatial tools earned him the esteemed Best PhD Thesis Award from RSP SOC University of Nottingham. With 10 plus international publications and upcoming edited book with Springer, Dr. Agarwal sir has proven expertise in remote sensing, GIS, hydraulics, and water quality. Sir has delivered numerous expert lectures at the various institutes and universities of international repute, including the University of Oxford, England. Additionally, sir has garnered numerous prestigious accolades, including the Harris Spotlight 2022 and Research Award 2022, Best PhD 2022 from University of Nottingham, Engineering Excellence Award, and many more. Thank you, sir, for accepting our invitation for the 138th webinar, which is quite popular among social media friends, yoga enthusiasts, students, staff of the institute. With these few words, now I would like to invite Dr. Ishwar Basavaraddi sir, Director Morarji Desai, National Institute of Yoga, Ministry of Ayush, Government of India, to say few words on today's topic, unearthing groundwater secrets with geospatial tools to address water challenges. So,
Om Shanti Shanti Shanti. Today's esteemed speaker, Dr. Vivek ji, my colleagues in the institute,
Shri Tayabalamji, Dr. Suman, Komal, and all my faculty members, student friends, and yoga enthusiasts joining this very famous Friday webinar from various social media platforms of the Institute. My hearty pranams to you all. I once again welcome Dr. Vivek Agarwal ji, a very famous scholar in his area of specialization. We heard about him. And it's my privilege once again to welcome you, Vivek ji. Hearty welcome ji. Today's topic is, it's not my area of specialization. I'm a yoga teacher, but Dr. Vivek ji will definitely emphasize on various aspects of unearthing groundwater secrets and also address the water challenges. But I can understand the importance of water and water challenges, especially in there are different challenges in the urban areas, in the metros, in the rural areas. So especially the groundwater is going down. If I take my village, when I was a child and I will get the water just 5 feet or 10 feet. Now we have more than 600 feet. Digging also we are not getting the water. So I have several fields and now none of them are irrigated. Earlier all of our fields were irrigated because we have plenty of groundwater. Now it is completely dry land because we don't get plenty of groundwater. We are depending on only the river water or something, rainwater, what we get. This may be the situation in the most part of the country. So that's one thing. That's why increasing the levels of groundwater, and this is very important, and that's why Government of India has taken many initiatives to improve this. I do understand Dr. Vivek will definitely emphasize on this. It's my personal request because we have to educate the people, students and faculties, importance of groundwater, unearthing groundwater. It's very, very important. The second one is water is very important for the human life, and how to make best use of the water to live healthy. Therefore, there are several challenges, and especially the drinking water. Most part of the India are not getting a good drinking water. So that's also one of the challenges, and many of the urban areas we use ROs, this, etc. But in the long run, that also creates some health hazards. That's why what are the natural processes to preserve the good drinking water and also make best use of that. I do know that it's not part of your lecture. Being an expert, you can also emphasize on this. Because whenever we talk about yoga, we are not only talk about yoga practices, but also the food what we eat, how free of pesticides and etc. We always emphasize because whatever we do yoga, but food what we eat makes a difference. Same thing, we have a preservation, but we have water. Water, how to preserve it, how to make best use of it, without wasting the water. What are the challenges we are going to face in the years to come if we don't save the water, every drop of the water? What are the challenges we are going to face? I do hope these are some of the issues to be addressed in his talk by Dr. Vivek Agarwal. With these few words, once again, Dr. Vivek, I will be eager to listen to you. Only thing is the end. I had one more lecture. I may leave at the end, but I will definitely be with you for more than half an hour. Thank you. Welcome, Dr. Vivek.
Thank you.
Now I request Dr. Vivek to deliver his talk.
I hope everyone can see my slide. Yeah. So, first of all, I would like to thank Honorable Director Sir, Dr. Ishwar Sir, and Communication Documentation Officer Sir, Dr. Taib Islam Sir, for providing me this golden opportunity to present at prestigious institute like Morarji Desai National Institute of Suruga. Also, I'd like to congratulate all the students, those who are listening. It gives me immense pleasure to see young boys and girls showing interest towards environmental challenges and water management. So I remember two lines by Dr. Aftab Iqbal. He even said, "नए दीवानों को देखे तो खुशी होती है, हम भी ऐसे ही थे जब आए थे वीराने में." So I see young boys and girls and see my and remember my undergraduate and postgraduate days and how we had something in heart to do something for the nature and for the environment, and then chose a path along it. So after this session, if any of the students wants to communicate more, please feel free. You have my LinkedIn, and I will also share my email address. So coming to the topic, unearthing groundwater secrets with geospatial tools to address water challenges. As Honorable Director has touched some of the points, we will touch that. I will introduce how geospatial tools, mainly remote sensing, how different satellites will be used for monitoring groundwater. So I'll also explain two satellites that we are used these days and how the basic concept behind that, and introduce some of the work that we have been doing. So these are some of the research areas that I usually work on: civil engineering and remote sensing GIS. An application is mostly related to hydrology, fluid mechanics, and water. So after the first Apollo mission, when the crew members saw the Earth from sky, they said it's a beautiful planet. It's a beautiful blue planet, right? No point in guessing why it is a blue planet, because there is lots of water beyond. But in this water, around 98% of water is in ocean, and that is salty, we cannot use. 1.6% is frozen, and around only 0.4% is fresh water. For our daily activities, we use this 0.4% of fresh water for various uses, whether it is domestic use, agriculture use, industrial use, or recreational use. So we are interested to know how, how the 0.4% water is distributed. We have some knowledge, but not as much as we'd like to have. Right. Also, this frozen water can be drawn, but it's very tough, and the ocean water is salty. So our main focus is always on this 0.4% of fresh water. Right. Now, the distribution of this fresh water is uneven across the globe, right? Both in spatial domain and temporal domain. So, in simple terms, to understand, this water is not uniformly distributed across different countries, different cities, right? And also not uniformly distributed every year. Some years we may have more rainfall and less rainfall. That is, in some areas, when the water availability becomes very high, the rainfall increase very high, then we see flood-like situations. So in certain areas, we see that there is no water at all, there is water scarcity, and we see drought-like situations. Right? So to understand this variability is very important. How much water is available and how it varies. Right. For example, this is the rainfall for last 100 years average and the global scenario. You can see from the map easily that some areas receive very heavy rainfall while some areas receive very less rainfall. For example, if you see the Indian part, obviously in Assam and Bihar side, there's lots of floods occurring every year. Why? Because water cycle is mainly dominated by rainfall, and we receive very high rainfall. We are not able to manage this water, so we lead to floods. Whereas in parts of Rajasthan, And on the western sides, we see less rainfall and we see a lot of uh, droughts and people struggling because of water scarcity. Right? So water is not evenly distributed, and as water management practices, we always think, can we transfer this water from here to here, right? Ideally, in an ideal world, it would be best if we can distribute this water everywhere, but it's not easy because of different geological and economic issues, right? So understanding this variability is important so that we can provide a proper solution. Where there is extra water, flood-like situation, how to manage this water. Where there is no water, how to provide extra water, how to recharge groundwater. So all those engineering problems can only be solved once we know the data, once we know where and what problem lies. So just like the spatial distribution, we have our temporal distribution, right? So for example, this is again for last 100 years, different parts, the change in rainfall. Right? So if you see in our southern Asia, we can see some years we have very high rainfall, while in some years we have very low rainfall. So if there is a consistent rainfall, also the planning and management will become easy. But it is not. Unfortunately, it is not. And so knowing the amount of rainfall or the amount of water available is very important. And doing that survey manually becomes very difficult, right? Managing the data manually becomes very difficult. So what we use these days is a new technology called remote sensing. We all have heard of various satellites in the sky. What satellites can do is they can cover large area, they can see whole country at one image, and they can give us regular, consistent data. So if a satellite has monthly data, it will give you data for every month. So we have reports for the whole area for months, and the monitoring becomes very easy. Once the monitoring becomes easy and we have accurate monitoring of data, we can predict how the future will behave, how much is there in chances of flood or drought, and then we can take mitigation scenarios. So total water storage. Total water storage, we all know, has got many different components. We have surface water, groundwater, soil moisture in areas of snow, there is snow covers, and there could be other ones. But the main thing to understand is that volume of water is directly related to mass of water, right? Because we know that density of water is constant. So volume is directly related to mass. And whenever we think of mass, we think of gravity. If you see this picture, apples falling on the head of a great scientist. So we all have studied in our preliminary classes. This great scientist is Sir Isaac Newton. He gave us the concept of gravity. He said that when observing changes in gravity can help us monitor changes in mass. Conclusion from his all gravitational experiments, right? So, basing using this principle that observing changes in gravity can help us monitor change in mass, we have launched a satellite called GRACE. GRACE stands for Gravity Recovery and Climate Experiments. So what does GRACE do? So you can see this GRACE 1 and GRACE 2. So these are two small satellites that are that has a distance of about 220 kilometers, and they are rotating in the sky at a distance of about 500 kilometers above the Earth's surface, and it constantly rotates the whole Earth, right? So if it has come here, so its repeat period is 1 month. So here, if it is here after 1 month rotating the whole Earth, it will come back again here. After another 1 month, it will come back again. So it covers the whole Earth in 1 month. Okay. Now, this satellite was launched in 2002 and it is still running. Okay. So what this satellite does is the value of acceleration due to gravity we all know in our preliminary classes is 9.81, right? But if you go more into the scientific details, it is 9.81270583 meter per second square. So the initial ones is for gravity values and shape of Earth and different other parameters. After points, the eighth decimal is for hydrology that accounts for water changes. Right? So you see, the remote sensing has become so powerful that from 500 kilometers above the Earth's surface, it can monitor changing gravity sixth position after decimal meters. Right? So you can just imagine how powerful remote sensing has become these days and how accurate data we get. Moreover, how this works, let us try to understand how this satellite works in very brief. Suppose this is a mountain here and this is a lake here. And this is twin satellite Grace 1 and Grace 2. They move, they first go over mountain and they first go over the lake, and the distance between them is recorded by the sensors. Right now, after certain months, there is a snowfall on this, and there is mass will increase because snow is accumulated here. So what will happen due to increase in mass, gravity values will increase. This increase in gravity value will decrease the distance between these two satellites because it will attract more. It will have the more gravity will attract these two satellites towards each other. And but this will remain same. Now, after certain days, suppose this ice melts and the water goes into the lake, right? What will happen because the mass has increased here? So this PL3 will be less than PL2. Because of the change in gravity, the distance between these two satellite changes, and the sensors are so powerful that even if the change in distance between them is as small as thickness of our human hair, right? You can see a human hair is how fine thin. Even that much distance changes between these two satellites, and it can be traced by the sensors in the satellite and then give us data, right? So without going much more into the details of engineering behind this satellite, I just want to introduce that monitoring of water resource from satellite is possible, and it gives us very accurate data on a very large scale and continuous data. So this data help us check what has happened in the past and help us predict what might happen in the future if steps are not taken, and thus help in decision making. Right? There are huge projects involving millions and millions of money for water management. Right? And those projects, for making decision in these projects, this data help us. So there are various application of this satellite. Groundwater change is one of the major application that me and my team looks. So what we do is this is the satellites, right? In this sky that is moving on. So we get image of the Earth. So this is the global image of the Earth for 1 month, right? So suppose we want to look at this area on the South America. So what we do is we look for every month, right? And then we just put our observation area and we get a time series like this, whether the water has gone down or water has gone up. Most simplistic language. What we try to do is over the period of time for a particular area, we try to study how the water has changed and the groundwater has gone down or whether it has improved, right? So there is another sensor satellite that we work on, that is INSAR. What is INSAR is interferometric synthetic aperture radar. So to understand this in more simplistic terms, what this sensor does is it throws a beam of electromagnetic radiation in microwave region. Okay, so we can see in electromagnetic spectrum, what we can see by our naked eye is visible ones, right? So red to blue lights we can see, but with more higher wavelengths we have microwave radiations, and the microwave radiations it just releases, it will strike the surface of Earth and it will go back. So it knows what time it released and at what time it will receive back, and it knows the speed of the radiation. So it can calculate how much distance it has traveled. Right. Now suppose this land has gone down. So there is a land subsidence or a landslide. So this land has gone down. So what it will do next time when it does this, it will take more time to go and it will calculate how much land has gone down. Right. This requires some very complex mathematical models to to release that we do. But in a more simplistic sum, what you can understand is when a lot of groundwater is taken up from the earth, what will happen because of the pore pressure changes, the land tends to go down because of the load from the subsurface. So especially in urban areas where there is a lot of construction, and there's heavy pressure on groundwater because of over extraction of groundwater, the land subsides. So we combine in our lab, what we do is we combine INSAR data and GRACE data, which are both very novel techniques, and we try to merge this data to see how much groundwater is extracted and how it can affect the livelihood directly. The civil engineering aspects of the buildings, how it can affect. Right? So this was one of the studies. So very briefly, I will introduce 2 to 3 studies that we have done. So again, just to give you a idea of how this satellites work. So this was a study on London area, on London city. So what we have done in this city is these are the INSAR results based on the INSAR satellite, and this is the GRACE results. Okay. So what the important point to match here is that this groundwater map by the Environment Agency of UK, and this is our results, right? We are the first one to give these results, and our results match very accurately about this is the contours of groundwater. So we can see in those areas where groundwater is red, that means the groundwater has gone down. The land is also going down, right? So we have shown that satellite can capture the signals very efficiently, and then this can provide a methodology to be used in future for further monitoring. So our this paper was published in Applied Sciences. So clearly here in this region, what happened is we have a lot of wells for extraction in London. So what happens because there is a lot of groundwater wells in extraction, 98 wells in this particular area. So because of groundwater extraction, the land has gone down. Similarly, in this area, there was a underground construction. So like in Delhi, we have metro construction. In London, we have got metro as well, right? So there is a CTRL line, metro line, that was being constructed during our observation period, and because of that, groundwater was diverted from that area. As soon as the groundwater was removed from that area, the land started going down, and so this was captured in again our satellite data. Converse to this, on this area, this is a very uh, well-maintained area where most of the rich people live. This is a high-profile area of London, central London. There are a lot of parks here, and groundwater is recharged regularly. It is made sure that no extraction is done. And because of the rainfall and the Thames River and the groundwater recharge, we see that the level of water rose slowly, which also rose because of which the land also started going up, which is also dangerous. Like over recharge will also try to rebound the ground, which is also dangerous for the stability of the structures above it. So what government does is now it has given license to many vendors where they can extract water from this area so that the level of water is balanced, right? So what we do is this kind of study does it makes sure that neither over extraction is done, neither under extraction is done, and neither over recharge is done. Right? So this study, this data helps the agencies to decide, the governments to decide how much water should be extracted and how much licensing should be given to companies from which area to extract and then divert it to the household. So there was this another study that because my heart is always close to India, so we wanted to run our model in Indian conditions as well. So we did a comparison study of London and Delhi. London and Delhi have very similar civil engineering, given that both of them have underground metros. Right? Because of the underground metros, there's a lot of construction that is very similar, especially the tunnels in the underground. Right. So we have done this comparative study, and that was again published in the Most Sensing Journal. This is a very reputed journal in our field. So what we have done is, if somebody is interested, you can find this. It's an open access channel. You can find my LinkedIn profile or certificate profile. You can definitely have a read. But I will just share a few of the interesting results here. Right. So if you see, this is the Kennington area in London and Battersea Power Station. Now, because of this power station, there is a lot of pressure on the groundwater, and we can easily see that Groundwater is going down and land is going down. For the Kennington area, what we have seen is we were expecting ideally that the groundwater is going up, so the land will go up throughout our observation period. But we saw that initially the land was going down, that is, land was subsiding, and then after certain period, land started rising. So this was because an underground tunnel was being made in this area. So because of the underground tunnel, what was done is groundwater was removed from this area for the construction. So land was going down. After construction finished in October 2017, so you could see that the signal called that from November 17, we could see a rise in subsidence. Right. It's a very complex phenomenon. I mean, it's not directly that you just take out water and the land will go down, and you fill some water, land will go up. There are many other geophysical phenomena that happen simultaneously. But in some areas, this can become the dominating factor, and it becomes very dangerous there, right? So that is what we are trying to do. Similarly, what happened on Delhi Haryana border, right? This is a Delhi Haryana border. We know that the population density in this area is very high pressure on the groundwater. So because of that over extraction of groundwater, there is land subsidence. You can see directly that land is going down from January to 21. Right? We have also sent these results to the Delhi government, and we are in touch to for a for a full-fledged focus study on Delhi groundwater. Right. So my supervisor, Professor Stuart Mars at Nottingham, and my professor Martin Kaplan, this is a team of three, and we have been in touch directly with the Delhi government, where using remote sensing tools, we are trying to monitor groundwater for Delhi because we all know that water scarcity is a big problem in Delhi now. There are many areas in and around Delhi where there is no groundwater, and water is being supplied with the help of tanks, right? So we want to make sure that this problem is solved in future, or at least not aggravated in future. So monitoring is very important. What we aim is to give them the hot spots where the groundwater is just gone down and immediate recharge is needed. And we can also try to we also have hope for some happy studies where we'll see that groundwater is good and there's a lot of water in the aquifer in some areas. So we'll try to focus more on extracting water for that. Because we need water. We just cannot say that water is going down, so stop extracting water. Because you have to meet the demand of people and the density of how's the population density, right? So we have to make sure that we provide water in a sustainable way, so that the future generations that are coming, there's some water left for them in good amount and good quality, right? So till now, what we have done is we have looked at the water quantity, how much water is available from satellite. But a bigger question is, what is the quality of this water, right? Observing different water quality parameters in water from remote sensing is a very challenging and a very new growing field. Lot of research is being done on this field. If we can monitor the groundwater from using satellite data. Monitoring water quality, like measuring water quality in labs, is easy. Very accurate information we can get running all the experiments on the water, but it is a very time consuming and a very expensive process to go to the field every time, get a sample, bring it to lab, do all the tests, and then give the report. It is almost impossible to do it over a very large area of, or if you want to do for whole Delhi area or whole India, it becomes very challenging. Like governments cannot invest so much of money in just monitoring. But if we find remote sensing tools, which unfortunately by now it's not possible to do accurate quality measurements, but everyday research is being done. We're launching new satellites, we're launching new sensors, new data processing algorithms are being done, and I'm sure that future is very bright, and the day is not far where we can monitor for quality from remote sensing as well. So this was the model that we built on the groundwater and deformation. Now, this we did a preliminary study on groundwater quality using remote sensing, right? And this was paper published in Applied Geography. You can also go and read about it. I've just present the result of sodium here. You know that sodium in water is is needed in some amount, but over water or like beyond some limit, it will start causing you health problems. So what we found is the red zones here. You see, this was for 20 years of data we have used, and the red zones here. Generally, the trend of London is that the sodium is higher in central London, and then expanding as you expand, go far away from central London, it reduces. This is mainly because of the population. Very high population is concentrated in central London. That is affecting the water quality. Right. This is we want more improvement in this model. We want much better results for water quality. Now we're happy with the water quantity results, but we're also working on new processed algorithms. Right now, as Honorable Director sir mentioned, that yoga is a science, and how can yoga help us water management? When this was offered to me to present a lecture at Yoga University, I think I got very excited because I know yoga is science and we need people from yoga field to come forward and take shake hands to protect our environment. Right? So there are many different ways in which you can contribute. First is obviously promoting conscious consumption, right? As yoga foster mindfulness, that can also give us good habits of water usage, right? Not wasting water and avoiding polluting water is very important. Inspiring environmental advocacy. This is again very important. Yogic principles can inspire practitioners to advocate for reasonable water management and conservation policies. Right? Spreading awareness, encouraging lifestyle changes. Lifestyle change can really help mitigating the challenge of water at household levels, and then building community building, right? Such as cleanup days in local water bodies or participation in water conservation projects really helps. We have seen some villages in Haryana, Rajasthan, they have now become self-reliant on water because of this community building. The lakes that got that completely soaked up, they are now recharged using the rainwater harvesting. As director sir was saying that when as a kid they used to get water at 10 feet and now not getting water at 100, 200 feet. So this is an alarming situation. And community we as a community can work very hard, have to work very hard to improve this. Right? Rainwater harvesting, I think, is very important. Capturing and storing rainwater for use can significantly reduce reliance on groundwater and surface water. Right? Then this is effective, especially in regions of heavy rainfall. For example, Delhi, North India receives very good rainfall, but but there is um, no storing of that water. All the water gets drained away into the drains and then into the rivers. If you are able to store that water efficiently, for cities like Delhi, there will be no problem of water. Right? Water recycling and water reuse is very important. So this can be done at a large scale or industrial scale, and this can also be done at households using grey water systems. Water conservation is important, right? There are many, and following public policies and regulations is very important. There is a big difference between the developed nations and developing the developed nations. So there is no regulations. We see in India there are many where there are tap wells and there is reckless drawing of groundwater, right? Without realizing that over the period of time, this water will the water level will reduce. Right? But in developed nations, there is check, you need proper licensing. So we as citizens, it becomes our duty to follow government rules. Right? So the situation is alarming, but there is hope. There is hope that with young people like you coming and getting aware and then working towards the improvement, we will definitely be able to tackle this problem. Right? So the thing, what I as a teacher, as a researcher, we also teach. As a teacher, what I usually do is a pedagogic approach wherein we want the students to participate as much we participate. It should be more of student talking, very active learning environment we have. And we have seen from our research that average learner retention after 24 hours is 90% of students. they participate in the class, right? We give you assignments, we ask you to present your topics, we ask you to give speeches, we ask you to solve questions on classroom boards, and there's a always try to include your students in our lectures. So this is some of the collaborative research that I've been doing involved in globally, mostly focusing on India and UK, but some in US, China as well, Germany as well. So this is some of the collaborative research, and these are some of the fundings that I've won and I've written. I know there are many students; they are very capable and talented, and they want to explore international opportunities, but sometimes lack of information becomes a hindrance. If there's any student who wants to explore more about any of the opportunities for about different scholarships or applying for funding, please feel free to ask me any questions you have. I will try to answer best. I have had some experience in applying various scholarships, so if I will be able to help, I'll be more than happy. And please feel free to join me. These are various ongoing projects, mainly focusing on India, because wherever I am in the on this world, I always focus on the problems related to India. So we know that the groundwater going down in Punjab is like no research question. Everybody knows it's going very down. The agriculture is getting affected because of this. So we're building a model to detect this groundwater decline and then the subsequent safety infrastructure. What we want to do is before the next Punjab election, we want to publish this study, because in India politics is everything, and if we can publish this before the Punjab election, I am sure that uh, study will be taken more seriously, if not by the ruling party, by the opposition party. And we just want the problem to be get solved. We don't have any political agenda, but we want the problem to get noticed and then to get solved. So we want to do that. Then the great satellite that we are seeing now, satellite has many different engineering aspects. So the groundwater soil moisture participation. From Indian perspective, we are trying to build a model there. And this is a paper we have worked on the ground qualitative research. This is already under review. And there are many other projects that we have been working on. So this was a very small, brief introduction of what work we have been doing and how we are trying to affect the society directly. If anyone is interested to know more in details, please feel free to contact me. I think my email ID and LinkedIn profiles are there. And yes, if you have any questions or any points to discussion, thank you so much for your time.
Thank you, sir, for presenting such an engaging session on such a unique topic, which is quite pertinent in today's times, especially when we have the World Environment Day approaching. And a few days back, we had the National Technology Day. So, this beautifully celebrated both the days and amalgamation of the two in a beautiful manner. Thank you so much, sir. So, we have received a few questions from few of our viewers. So, the very first question is, what are the potential connections between yoga and water management which can be explored using geospatial tools?
Yes, I think this is again a very interesting and very novel topic, right? Yoga, like we expect, more of um, self body related, right? What we eat, what we drink, and then that is affected by the environment we live in, and then that environment can be changed by the geospatial tool. So can be traced by the geospatial tool. So it is a circle of from whole to from large to small. From looking at the larger perspective, geospatial tools help us to look acts as a large one unit, and then environment, and then our
To
body as
interrupt
a
you, sir, we have received another question that is quite similar to this. So that you can provide a combined answer of both the questions. So, are there any studies or research using geospatial tools or techniques to understand the relationship between yoga practices? So, there are certain centers of yoga. Okay, and they do yoga practices there for yoga practices and retreats. Okay, so are there any studies which are being conducted or which are there in process around such areas to study the local the water availability in those local areas?
Um, I mean, this is again a very interesting topic, and I will definitely try to uh, introduce some research questions in my field after today's session. Because particularly personally, I've never thought of this before, but after interacting with after this session, definitely it is on my cards. And I've not come across any specific study that is linked yoga and geospatial tools as such. But if there is I will go through the literature definitely, and if there is something I will share links with you, and then you can share with the students. But if there is not, then I think this is an unexplored section. And even if it is there, then it is very scarcely explored section. So there is a lot that can be done there because it is a cyclic process, right? Like I was saying that geospatial tools can, the remote sensing can help us to look Earth and environment as a whole, and then yoga help us to look as individuals, and then take that, and then there's amalgam between both. So definitely water conservation is a part. Like I've said that few points how yoga can promote water
Right.
conservation, and how it can effectively make sure that the water we are drinking, and then consequently the food we are having, because India is a agro-based economy. Everything depends on the water. Everything, so food also depends on the quality of water and the quantity of water we provide. So yes, obviously it is a very interesting topic and something to be explored about in more details. The present I cannot give you a very exact answer of how much work has been done in this, but I can definitely sense that much more work will be done in future.
Okay. And so you did mention about some opportunities which our students can get abroad. So if you could name a few or mention a few here that would help our students.
Yes, I mean these days there are many opportunities, especially if you are looking for UK. Then there is and for UK there is one called Commonwealth Scholarship. Right? Commonwealth is for all the countries that UK have been those have been colonies of UK, and Commonwealth is for all fields. So it is not just for science and technology, for social science, I'm sure for yoga, humanities. So Commonwealth scholarship is something students can work. It is very prestigious. They provide good financial support as well, and then technical and scientific support as well. Whatever you need. There is one called Marie Curie. So I can provide you the links of those. Right? So Marie Curie is one very important. The Marie Curie where the scientist does work in chemistry basically. So if you are anywhere related to chemistry, so like water molecular water is completely chemistry, right? If anybody is wanting to work with that, Marie Curie is a good option. So many universities they have their own scholarship as well. Like the one that I got PhD for was completely funded by UK government, but it was engineering excellence scholarship, and it was mainly for the University of Ireland. That is university specific scholarship. So students can go to the website. So if somebody wants to work with Oxford or Cambridge, so Oxford and Cambridge they have their own many scholarships. So you just go to their websites and it's all there on the right. So
Okay.
it's and in India we have DST, I think Department of Science and Technology. You must have heard. So they provide a lot of funding to do research in foreign countries as well. They're having collaboration country-wise. So yeah, I mean, if you just explore some links on the Google for some time, you start getting a feel of what opportunities you have, and they vary field to field. Like for every different field, you will have there. But these days, there's lot of opportunities, and we see a lot of Indian students coming to UK, coming to Europe for research. So if anybody has like any specific question, these are some of the names that are just coming to my mind. There are many others, I'm sure. If any student have any specific question or they're looking for any specific opportunity they want to discuss, then welcome.
Okay, okay. Sir, it was wonderful to have you today, and you beautifully completed the presentation in full cycle by presenting the slide on yoga, and Director Sir started the today's lecture with the same points, that how yoga promotes that consciousness and how it advocates an eco-friendly lifestyle, and how you linked that with your lecture with geospatial technologies in environment. So thank you so much, sir, for presenting such a wonderful lecture. It was great to have you today.
Thank you,
So
Dr. Sumi. Pleasure is
we
all
will
mine.
conclude this session. Thank you, sir. We will conclude the session with Shanti Part.
Yeah, for sure.
Om Shanti Shanti Shanti.
Thank you,
you,
Dr.
sir.
Sumi. And see you.
Thank you, sir.